Uh, so if we talk about support vector machines, SVMs, these are like one of the most powerful supervised learning algorithms in machine learning and artificial intelligence. They are primarily used for classification and regression tasks. SVMs operate by finding the optimal hyperplane that separates data points into different classes within the maximum margins. It was developed in 1990s by Vladimir Vapnik and his colleagues. SVM has been instrumental in solving complex real world problems due to their robustness and versatility. And if we talk about theoretical foundations of FEM. Let's start with the linear separa- separability and hyperplanes. So hyperplane is a decision boundary that separate data in a dimensional space for separable data. Uh, a hyperplane can divide the data points into different classes without errors. Like in two dimensions, they correspond to a straight line and then the concept of margin, where the margin is the distance between the hyperplane and the nearest data points from each class. So SVM aims to maximize the margin to ensure robust classification, and data points lying on the margin boundary are called support vectors, which play a critical role in defining the hyperplane. And if we talk about the mathematical foundation of SVM, the problem of finding optimal hyperplane is formulated as a convex optimization model. Given a dataset where the feature vectors are the class labels, objective is to either minimize or subject to all. So, so then the next topic is kernel method. So first we have to understand the kernels. So kernels enable SVM to handle non-linear separable data by mapping input feature into higher dimensional space. So this transformation make it easier to find separating hyperplane in the new space. So if we talk about popular kernels, functions are like linear kernel, polynomial kernel, radial basis function kernel, that is like RPF kernel, then is sigmoid kernel. Uh, if we talk about kernel trick and their importance, kernel trick allows SVM to perform computation in the feature space without explicitly transforming the data. This reduces the computational complexity and makes the SVM highly efficient for high dimensional data. And if we talk about classifications of SVM, start with the binary classification. In binary classification, SVM separate two classes by finding optimal hyperplane. The decision function is given by multi-classification for multi-class problems. Techniques like one-on-one, one versus one, OVO, one versus rest, OV are used. These methods decompose the multi-class problem into multi-binary class tasks. And if we talk about advantages and the limitation, the advantages are like highly effective in high dimensional spaces and works well for both linear and non-linear problems. However, if we talk about limitations, these are computationally intensive for large data sets, and these are like very sensitive to parameter selection. And if we talk about SVM for the regressions, so support vector regressions adapts the principles of SVM for regression tasks. Instead of finding a hyperplane to classify data, SVR identifies a tube within each data points where the data points lie. The objective is to minimize the error while maintaining the robustness. And if we talk about applications of SVR, it is widely used in fields like series prediction, financial modeling, and forecasting. And moving to the next topic, which is optimization in the SVM. So first is quadratic programming, which is the optimization problem in SVM is a quadratic programming QP problem, where the goal is to minimize the quadratic objective function subject to linear constraints. And solving SVM optimization problems, so methods like sequential minimal optimization, SMO, and language multipliers are used to solve SVM optimization problems efficiently. And in terms of practical implementation, so library they have certain libraries and frameworks. So the popular libraries like scikit-learn, TensorFlow, libsvm provide a robust implementation of SVM. And if we talk about hyperparameter tuning, so key parameters such as regularization parameter and the kernel coefficient that need to be fine-tuned for optimal performance. And if we talk about real-world use cases, these are like handwritten digit recognition, spam email detection, sentiment analysis, and in terms of applications of SVM in AI, so first is image recognition. So SVMs are used for object detection, facial recognition. Then is NLP applications like text classification, sentiment analysis, entity recognition, and bioinformatics. SVMs aid in protein classification, gene expression analysis, disease prediction, and it's also used in finance and stock market prediction. SVMs are used to predict stock prices, analyze market trends, and in terms of advanced concepts in SVMs is soft margin and C parameter, which is the which allows some misclassifications to achieve better trade-off between margin width and classification accuracy. The parameter controls the trade-off, and overfitting and underfitting. It's a proper parameter tuning. Cross validations are essential to avoid overfitting or underfitting. Then is SVM in imbalanced datasets. So technique like cost-sensitive learning, resampling are used to handle imbalanced dataset effectively. And however, there are certain challenges in this. So in terms of like challenges, they have like scalability issues. So SVM struggles with large dataset due to their computational complexity, advancements in kernel methods. Uh, so research is going on to develop more efficient and expressive kernels. Then integration with uh, the deep learning. So hybrid models combining SVM and deep learning architectures are emerging as a promise area of search. So these are the future direction. And in terms of conclusion, so support vector machines are like cornerstones of machine learning and AI, and their ability to solve complex classification and regression tasks with high accuracy, it makes more them indispensable in various domains. Despite challenges like scalability, advancement in algorithms, hybrid approaches continue to enhance their application. Thank you for watching.